In this lesson, we'd like to introduce the notion of probability, and to do that we're going to start with the notation that we use for probability and also talk a little bit about some vocabulary. We are going to be seeing this kind of a symbol again and again. It means the probability of the event A, so we need to know a little bit about events, where they come from, and then what we mean by probabilities. First of all, this notation looks a lot like notation you've seen before, say in intermediate algebra. You saw function notation where, say, f of x equals 2x plus 1, so that f of 3, you just replace the x by 3 on both sides of the equation, do the arithmetic, and find out that f of 3 is equal to 6 plus 1 or 7. Now, the same thing is happening here in this notation. We have a function in mind. It's the probability function, and its input now is not a number but rather an event. What is an event? Well, an event is something that comes from an experiment. An experiment is simply any process that produces a definite outcome, and an outcome is the result of a single trial of that experiment. So for example, we could say flip a coin once, and the possible outcomes would be either head or tail. Or we might observe a family that has 3 children in succession, and say count the number of girls and the number of boys. That could be the experiment and the different outcomes that could occur. An event is any combination of outcomes, and sometimes events that are not simple outcomes are referred to as compounds. Let's take some examples here. Suppose, for instance, the event AE might be the event that it rains today. Now, the implied experiment is we just pay attention. We notice that there's either rain or there isn't, and so the event A, it rained, that would be a simple event or an outcome for this experiment. A might be that in the next flip of a coin it will come up tails. Once again, that's simple, a simple event, or you could say it's an outcome because we run the experiment once. That's one of the simple different outcomes that could occur in running the experiment once. Now, by contrast, suppose that the event B is that the next 3 flips of a coin will have at least 2 heads. Now, this is not a simple outcome. It is a valid event, but it's not a simple outcome, and here's why. If we were to flip the coin 3 times, well, here's what could happen. We could get 3 heads, we could get a tail and 2 heads. The tail could occur last, in the middle, or first, and then, of course, it's also possible that we could have 2 tails, or we could have no heads at all. We could have all tails. So I've listed the first 4 here, and then there are another 4 for 2 heads and for 2 tails and for 3 tails. Now, the event in the example is that we have 2 or more heads. That's definitely compound because here's the event. 2 or more heads, 2 heads for this one, 2 heads for this one, and for this one, here there are 3. That qualifies as 2 or more. So there are 4 different outcomes on the physical experiment that gives this particular event, and therefore we say that this particular event, B, is compound. C might be the event that on the next hand of poker I will get 2 aces. That's definitely a compound event. For those of you who know the game, realize that there are many, many ways you could get a poker hand that has 2 aces in it. And therefore, those are compound events. They are not simple outcomes. These first 2 are simple events, also known as outcomes. All right, now, looking back at our notation here, we want the probability of an event. We've just talked about what events are. Events come from experiments, and now we'd like to know what the probability of an event is. And the probability is simply a measure of how likely we are to get a particular outcome. Now, it turns out that probabilities always range from 0 to 1. We'll say a little bit more about that in the sequel. But if the probability of an event is 0, we say that the event is absolutely impossible. It could never occur under any circumstances. If the probability of the event is 1, then the event is certain to occur. It must happen no matter what the circumstances when we run our experiment. Now, the idea of probability then, the most common way of defining it is to use what's known as the frequentist interpretation. In other words, how frequently does this event occur compared to the universe of all the times that the experiment is run. So you have an experiment in mind, you run it many times. It may be a very large number of times for this to work out nicely, but there is a number that's big enough that'll work. You run the experiment a large enough number of times. You simply count the number of times that the event occurred, divide by the total number of times you ran the experiment. You could shorten that a little bit here. The number of times E occurs, divide by the number of trials, and that gives you an approximation to the probability that the event E occurs. So the probability of E is theoretically run the experiment many, many times. Number of times the event occurs divided by the number of trials. Now, officially, if you wanted the exact definition, you'd start talking about doing something like repeating this experiment over and over and over into infinity, and always updating. Each time you run the experiment, you update your ratio, and the claim is that as you do this often enough, you as the number of trials gets larger and larger towards infinity, then this ratio will get closer and closer eventually to the probability of the event E. Now, the law of large numbers tells us that you actually don't have to run the experiment infinitely many times. If you run it a large enough number of times, this fraction here will start getting close to the true probability of the event. Now, when you look at that definition, something you should notice is that probabilities, at least in this definition, are ratios. And this count here is taken out of this count here. So if you ran the experiment 100 times, the minimum number of times the event E could have occurred, of course, is 0. You couldn't have less than that. And if you ran the experiment 100 times, you couldn't have gotten the event to occur more than 100 times. So that is where these limitations come from. A probability is automatically no less than 0, because you can't have the event occurring less than 0 times, and no more than 1. Why? Because the number of times E occurs could be as large as the number of trials, but certainly not any bigger. So there aren't any negative probabilities. There aren't any probabilities that are greater than 1. If you ever think you've computed one, what that's telling you is you just made an error. So you want to go back and correct that. Maybe just a word of advice for students taking exams and quizzes. You know, if you get started on a problem and you don't have time to fix it, and your probability you've computed comes out to be something like 3.7, well, if you don't have time to fix it, it would probably be a good idea to at least put a note on there for your teacher to say, I know this is not correct, probability couldn't be more than 1, but I don't have time to fix this. So then at least it removes the question of whether you're aware that there are limits to the amount of how small or how big a probability can be. The last thing I do want to make mention of is this. Sometimes you'll hear people in informal situations talking about attempting the impossible and going for it when it just everyone knows it can't be done. Well, not in math. We never use the words impossible or certain to mean anything other than their literal meaning. To say that an event is impossible means that its probability is exactly 0 no matter what the circumstances, no matter how hard you try. It just simply could not happen. Therefore, trying an impossible trying to achieve something impossible would be truly stupid. You're wasting your time. It could never happen. So in mathematics, we don't ever use certain and impossible in sort of in order to exaggerate or to have a metaphorical meaning for them. They actually mean impossible or certain, and therefore you should only use them in that way.